Question number 1. Butane nitrile is formed by the action of KCN with. What is nitrile? Nitriles are nothing but cyanide, CN. So we can write in general RCN. This RCN is formed by the reaction with the potassium cyanide KCN. So K plus and Cn minus we have. It should react with not alcohol. Alcohol does not react here. Okay, to give cyanides. Therefore, it should be either butyl chloride or propyl chloride. So let me write down in general RX alkyl halide. So nucleophile Cn minus attacks the carbon atom and the halogen goes out to give RCN. Okay, R C triple bond N. Cyanides or they are called the nitriles. Now it should be butane nitrile. But how many carbon atoms? 4. 1, 2, 3, 4. Butane nitrile nitrogen. Okay, with the triple bond. It should be CH3, CH2, CH2CN. Correct? So this is a butane nitrile, or this can also be called as propyl cyanide. Propyl cyanide. Okay. So, what is the corresponding alkyl halide? It should be chloride. Which chloride? Cl should I bring in? Okay. So, X is replaced by Cn. So, Cn is the group now that comes in. Therefore, compound should be containing 3 carbon atoms. Okay. It should be CH3, CH2, CH2, Cl. Therefore, Cl is replaced by the potassium cyanide K plus and Cn minus. Okay. So KCl is the side product. It should be propyl chloride. Correct? The answer is option number 4. Propyl chloride. N-propyl chloride will give the propyl cyanide, which is nothing but butane nitrile, 4 carbon atoms with a nitrile. Clear? Question number 2. Alkyl halides are converted to into alcohol, the ROH, by which reaction? Remove X and replace by the OH group. So it is known as the substitution, right? So answer is option number 2. How to carry out substitution? Either can make use of aqueous sodium hydroxide or the aqueous potassium hydroxide, or simply hydrolyze using the water, right? Question number 3. A racemic mixture obtained when an optically active alkyl halide reacts with Cn minus cyanide. The alkyl halide most likely to be. Remember, there are two types of mechanism, SN1 mechanism and SN2 mechanism. Okay. For SN2 mechanism, tertiary alkyl halide reacts faster compared to secondary compared to primary. Whereas for SN1 mechanism, primary greater than secondary greater than tertiary alkyl halides. Remember, in case of SN1 mechanism, there is a carbocation mechanism, and in that carbocation mechanism, tertiary carbocation is more stable. Remember, when the carbocation comes tertiary, more stable. So there always be the racemic mixture that is formed. Racemic mixture. In case of SN2 mechanism, there is a transition state that is formed. Transition state that is formed. Okay. And here, this will lead to always inversion of configuration. Inversion of configuration. Right? Okay. Therefore, what is the answer? Racemic mixture. Therefore, the answer should be tertiary. Third one is the answer. Fine. Question number 4. Which is the attacking reagent involved in the Friedel-Crafts reaction? Okay. Friedel-Crafts reaction generally for aromatic compounds. Generally for aromatic compound like benzene or benzene derivatives. In Friedel-Crafts reaction, Friedel-Crafts alkylation, we can use this one, methyl chloride. In Friedel-Crafts acylation, we can make use of acetyl chloride. In the presence of anhydrous aluminium chloride, it generates the methyl carbocation, and in this case, acyl cation, carbocation. Therefore, these are actually electrophile. Electrophile easily attacks electron-rich benzene rings or aromatic compounds. So the answer is option number 1. Okay. Question number 5. Name of the product obtained by the addition of HI to propene in the presence of peroxide. Propene CH3 CH double bond CH2 reacts with the HI. So I can write H plus and I minus. So remember here two rules. One is the Markovnikov rule and anti-Markovnikov rule. Anti-Markovnikov rule is also known as the peroxide. Okay. Now if I take HI here, H plus will go to that double bonded carbon containing more number of hydrogen. Negative part will go to that carbon containing lesser number of hydrogen. Therefore, I should get CH3, CHI, and CH3. This is Markovnikov's rule. Okay. Remember, anti-Markovnikov's rule or peroxide referred only for HBr, not for HI or HCl. Remember. Okay. Now, in this case, HI is there. Whether there is a peroxide catalyst or no peroxide, that doesn't matter. The product would remain the same. Okay. I should get, it should be 2-iodopropane itself. 2-iodopropane. Okay. Therefore, the answer should be option number 2. 2-iodopropane. Clear? Remember, anti-Markovnikov's rule is for HBr addition only, not for HI and HCl. So even if there is a HI and HCl, if there is a peroxide or peroxide, always remember Markovnikov's rule here. Okay. So Markovnikov's rule only for HBr, in the presence of peroxide. In the presence of peroxide, then only it is the anti-Markovnikov's rule. All other combinations are Markovnikov's rule. Okay. Question number 6. When 1-chlorobutane and 2-chloropropane treated with the metallic sodium in ether, we get, when there is a sodium and alkyl halide comes, remember this is a worse reaction, but there are two different types of alkyl halides. 1-chlorobutane, so I can write CH3, CH2, CH2, CH2 and Cl. Carbon number 1, carbon number 2, carbon number 3, carbon number 1 chloro. 2-chloropropane, I would write like this, CH3, CH, single bond Cl and CH3. This is carbon number 1, carbon number 2, carbon number 3, 2-chloro. In the presence of metallic sodium, 2 moles. Remove 2 moles of sodium chloride. Now break this carbon chlorine and carbon chlorine, form new bond CH3, CH2, 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 first one. And the second one to the middle carbon atom of the propyl group. So it should be like this, CH3. Okay. Select the longest chain of carbon atom. So carbon number 1, carbon number 2 here, because start from that side where there is a substituent. Carbon number 3, carbon number 4, carbon number 5 and carbon number 6. So it is the X chain, longest chain. On second carbon atom there is a substituent methyl. Should be 2-methyl-hexane. Okay. So the answer is option number 1, 2-methyl-hexane. Question number 7. Arrange the following isomeric bromides where the molecular formula is same. Order of decreasing relative rates for SN2 mechanism. Remember, for SN2 mechanism, primary should come first, then the secondary, then the tertiary. Okay. And if there is a branching increasing, the SN2 reactor decreases. Now see this one. This first example. Yeah, this carbon is attached to 3 more carbon atoms, right? So this will be tertiary alkyl halide. This carbon atom attached to only 1 carbon. Second example here, Roman number 2. So this is the primary. Okay, here this carbon atom is a secondary now. So secondary alkyl halide. Okay, and here we have got again the primary. primary alkyl halide. Hope this is clear. Okay, in this primary there are two primary option number example number 2 and example number 4 here. Okay, now if you see example number 4, there's a linear chain branching is there at the end, correct? So that is the branching and the BR are away from each other. In the example number 2, okay, on carbon number 2 only the branching start. Whereas the example number 4, branching started carbon number 1, carbon number 2, carbon number 3, carbon number 4. Okay. Therefore, option number 4 should be more reactive because the branching and the halogen are far away from each other. Then go for the example number 2 here. These are the primaries. Then go for secondary and tertiary. Then secondary comes on example number 3. Example number 3 is the tertiary, right? And example number 1 is the, sorry, example number 3 is the secondary, example number 3 is the tertiary, and first two are, that is the example number 4 and example number 2 are primaries. Okay, so the Roman number should be, so answer should be option number 2, right? Fourth greater than, second greater than, to third greater than 1. Okay, this should be the answer. Clear? Question number 8. Arrange the following compounds in the increasing order of the densities. Remember, density is directly proportional to molar mass. As the molar mass increases, density increases. Now see here, in the examples 1, 2, 3, 4, as the size of the halogen, as the atomic mass of the halogen goes on increases, the density also increases, correct? So the least should be for the benzene. And if you see carefully, the same order, 1 should be lower compared to 2, compared to 3, compared to 4. Clear? So answer should be option number 1, right? Question number 9. Which of the following is not chiral? For the compound to be chiral, there must be at least one carbon atom which is attached to 4 different groups, which is known as the chiral carbon or asymmetric carbon. Let's see the example number 1. First option. Propanoic acid. 1, 2, 3. Acid. Propanoic acid. Which propanoic acid? 2. Carbon number 1, carbon number 2 here. So it is a 2-hydroxy propanoic acid, remaining CH3 and your hydrogen, correct? So this carbon atom attached to 4 different groups. Can you see? Therefore, answer, this is the chiral molecule. Okay, chiral compound. 2-butanol. Carbon number 1, carbon number 2, carbon number 3, carbon number 4. This is carbon number 2, OH is here. So remaining should be CH3, CH here, CH2 and CH3. 4 different groups are there. 1, 2, 3 and 4. Therefore, second carbon is chiral carbon. Option number 3, 2, 3 dibromopentane. 1, 2, 3, 4, 5. Pentane. 1, 2, 3, 4, 5. Pentane. 2, 3. 2, 3. 2, 3. Dibromo. Okay, dibromo. 2, 3 dibromo. So this should be CH3. This is hydrogen. This is hydrogen. This is a CH2 and this is a CH3. This carbon atom, we are marked as the star. 1, 2, 3 and 4 different groups are there, correct? Similarly, the next carbon is atom also the chiral carbon atom. You can see there. So that is also chiral. Last one, meaning fourth option. Pentane. Carbon number 1, carbon number 2, carbon number 3, carbon number 4 and carbon number 5. 3 bromo. Okay. So here CH3 is the CH2. This is a CH2 and this is a CH3 and this is hydrogen. Okay. This is attached to group number 1, group number 2. But see carefully, third group and the fourth group are same. These two groups are same. Therefore, this carbon is not chiral. There is no chiral carbon atom. Therefore, option number 4, this compound is not chiral. Okay. Question number 10. When phenyl magnesium bromide, Grignard reagent, RMGX. If I write polarity, this is a delta minus, remaining is a delta plus, I can write. Reacts the tertiary butanol. Okay, alcohol, reacts the alcohol. Even alcohols are acidic. So I can write delta plus, remaining part delta minus. So what will happen now? The nucleophilic R minus can take up the acidic hydrogen, so it get RH and remaining the magnesium salt MgX and OR. So we can get here hydrocarbon. Now phenyl, benzene, phenyl, magnesium bromide, phenyl magnesium bromide reacts with the alcohol, tertiary-butyl alcohol. Let me write ROH, tertiary-butyl alcohol. So acidic hydrogen is there, delta plus and delta minus. Okay, therefore the phenyl negative charge can take up the acidic H plus. So it gives actually benzene ring back. Okay, so the answer is option number one. Clear? Thanks for watching. Have a nice day.